Okay, so we're going to do another problem where we're doing some combustion. So this is a problem where you have to provide a balanced chemical equation, right? We have over here, we have these two reactants. One of them is the hydrocarbon, the other is oxygen. And we're given the coefficient for the hydrocarbon, but we're not given the coefficient for the oxygen. Then we have down here, these are the products. So there are two products in combustion of any hydrocarbon, complete combustion. We're not given their formulas or their structures, but we are given their coefficients. So let's see if we can turn this into a normal looking equation, right? So we have a coefficient of 2 in front of our hydrocarbon. So this is drawn out this way, but all the other ways, you could just show the molecular formula. So let me number my carbons 1, 2, 3, 4, 5, 6. So that's 2 is a coefficient, and then it's C6. And then look at your hydrogens. How many hydrogens? You got 3 on each end, that's 6. And then 7, 8, 9, 10, 11, 12, 13, 14. So H14. And you could have also looked at this and said, that's an alkane. And so it would be the number of carbons, right? It's CnH2n plus 2. So it would be 2 times 6 is 12 plus 2 is 14. So either way, you could do that. Plus some coefficient that we're not given, O2, yields, oh, we're given that 12 of something, we don't know what that is, plus 14 of something. Okay, so what are those somethings? Well, this is combustion. So there are only two types of combustion, complete combustion and incomplete combustion. If it's complete combustion, we're going to make CO2 and we're going to make water. So one of those two is going to be CO2. The other is going to be water. Now we don't know which one goes where yet. So we got to kind of figure that out. If it were incomplete combustion, they would have to say it was incomplete and you would be making carbon monoxide, but it's not. It is complete combustion. So now we kind of have to look at what are we going to be making? Well, over here on the reactant side, let me look at how many carbons I have. I have a subscript of 6, and then I have a coefficient of 2. So 6 times 2 is equal to 12. So I know that I'm going to have 12 total carbons in the reactants, and therefore I need 12 total carbons in the products. So I know I'm going to have 12 CO2. And then if you look at, this has to be water. It just has to be because there's no other place for it. But let's go ahead and try and balance this equation just so that we can get our coefficient right here for the O2. All right, so let's see. So let's make sure, right? Let's do our hydrogen. Our hydrogen over here, we have a subscript of 14. So 14 times 2, that's 28. And then oxygen, well, we can't do that quite yet. So let's go and do the other side. Let's make sure we're balanced. Carbon, we have a subscript of 1, even though we don't write it. So that'd be 1 times my coefficient, which is 12. That gives me 12. So my carbon's balanced. That's good. Now hydrogen's over here. So we have a subscript of 2. 2 times 14 is 28. So my hydrogen check out. Now my oxygen, be careful because you have to pull oxygen from 2 different places, right? So oxygen here, we have 2 times 12. So 12 times 2. So that's 424, right? And then plus, we have some oxygen over here in water. So that's plus, and we have a subscript of 1, right? So we just don't write it. So we say 1 times 14 is 14. So 24 and 24, that's 8, that's 38. So now all you have to do is say, what do I need to put in my coefficient over here in order to make this balance? So some number times 2 should give me 38, right? So I'm sorry, y'all, that is my dog drinking water and she's super noisy. All right, so what do we have here? Just what should you put in your coefficient? And you should put, right, that should be 2 times 20 would give you 40, so 19, right? So what goes in the homework program, you would put a coefficient of 19 here. Now you have to draw the structure of the products here. So I'm gonna have to draw the structure of CO2. Well, what is CO2? That's carbon and it's bonded to 2 oxygens. So you would have to draw the Lewis structure in order to get those oxygens. And so we know that it looks like this. And I don't know if they're looking for lone pairs on those oxygens, but you would have 2 lone pairs. They might not want them. And then water, we know we've drawn water before, right? That's oxygen and then 2 hydrogens, and oxygen has the lone pairs. So that should answer everything. Hope that helps.